Welcome to academic discussion of Presidency University Physics Society. Today our speaker is Mr. Suvamay Pramanik. He is PhD scholar of our department, Department of Physics, Presidency University. So, he's the topic.
Thank you for this nice introduction. Hello everyone. So today basically I am going to discuss about some electrical devices. A new technology. I think you will get some knowledge from this talk. Okay. So before beginning of this talk, just to gather, I am just curious. So want to know that what is physics? What do you mean? If I ask you that what is physics? You know what is physics? Physics. What is physics? If any professor asks,
studying some mathematics and scientific.
physics is related to the nature. Actually, physics is related to the nature, and not to study the nature. And actually, physics means that to study the nature or to gain the knowledge of nature. Yes. So actually, this is the very good definition of physics. Physics is the science that discovers and describes the fundamental laws of nature governing matter, energy, space, and time. So basically, this is very hard definition. And for me and all of us, that physics is very interesting. So now, today, we are going to discuss something very interesting. Okay, so before beginning or before I start, we want to know or we have to know some term. A term is called sustainable development. So what does this mean? Sustainable development means that now in this time we are happy enjoying all our facilities and we want our future generation to be happy as well. That when আমরা যদি 6 চলে এলাম তাহলে কিছু করে এটা হবে so we focus on the sustainable development and sustainable development. And this sustainable development actually works on three pillars: present need, future capability, and balanced growth. Okay, but there are some problems like waste. Waste is a waste burden, and global pollution is a main problem. So this was the environmental impact, resource losses. Okay, and for this what we can do, we can reduce, reuse, and recycle to manage this waste. Okay, and another thing which contributes to the sustainable development is actually the renewable energy and its storage. So we all know about solar power, wind energy, and we know we demand for good energy storage facilities to store the. Okay, so now we can start our discussion that our goal, what I have said, that our goal is to achieve sustainable development. In this process, so what we aim for? We aim for investing in renewable energy sources. Okay, so as an example, I have stated that why also in this process we demand for good energy storage devices. So why we need good energy storage devices in this sustainable development process? I have explained it with an example. We can't use our phone with just solar and battery. We need battery. So if we are at a night, we are chatting with someone or whatever, then you need the battery of this phone to mobile phone to be working. Okay, so but in this process, we face some problem, that is the virus burden and pollution. So what do? We do the recycling I have said earlier. So basically, in our method, our process, we have connected this recycling of biowaste burden with the producing good energy storage devices. Okay, basically we have all learned about the capacitors. So I have placed too many capacitors on the screen. Some of them we have faced in our gateway physics lab or anywhere. There are capacitors from this brand. Okay, so basically they are the mainly ceramic capacitors or fluid capacitors. The basic principle of capacitors, they work on a electrostatic storage device that actually they store charge electrostatically, and this is the main formula of capacitance. Capacitance means the measure of how much charge it can store. Okay, so this capacitance is directly proportional to the surface area of this capacitor plates. Okay, but in this case of dielectric capacitors, where there is a dielectric material placed between the plates, we cannot modify or increase this surface area. We need larger amount of surface area. Then we need larger, big size capacitors, but we actually cannot use them in our practical life. Okay, so what we do, we introduce a new thing. This is called a supercapacitor or ultra capacitor. So basically, these supercapacitors bridges the gap between these batteries and the capacitors. Okay, this is a remote load or power transmitters. I'm discussing these terms. But the main construction of the capacitor, you can see the supercapacitor. This supercapacitor composed of mainly three things. Three things are electrode, electrolyte, and a separator. So again, this electrode consists of a current collector, and on this current collector, a active material is put. Okay, so now please remember this active material. I will be producing this active material through some processes of the biowaste materials. Okay, so you can see this is a very good comparison between capacitors, supercapacitors, and batteries. Actually, capacitors have a high cycle life. That means you can use these capacitors for long times, for years, and it will give you the same capacitance value for this time too. And it has high power density, and moderate energy density. Whereas capacitors, the ordinary capacitors give us high power, but energy density is very low. And in case of batteries give us low power density but high energy density. But these are all startups. How do you relate in practical life? What are the power density? What are the higher energy density? So just to understand this, you can see this. This is a very good diagram. So you can imagine a low power density but high energy density device like a battery as a big tank, but the rate of flow of water coming out of this pipe is very small. But in case of supercapacitors, high power density and low energy density means you have a medium or small tank, but the rate of flow of discharge of water is very high. That is, it can deliver charge or store charge very rapidly. Okay, so this is the charge storage mechanism of a supercapacitor. So I have already said there are active material, ferrite active material, and electrolytes. So electrolytes are three ions. We all know that etc. So when we apply voltage, the positive and negative ions get separated, and when we connect this capacitor with supercapacitor with a load, this may the voltage identified or voltage or current identified. So this is the current potential graph of the supercapacitors. I will be again discussing about this for later days. Okay, so basically the supercapacitors are consist of electrode material, electrolyte. So in our process, I want to make this electrode material, that active material, that part, with something that comes from nature, produced with water, and one of the main source of pollution. So what are the so here the biomass waste. Okay, so in our case we have taken the Litchi. So biowaste are something we all know, we have vegetables, the waste of vegetable foods, anything that we observe in our practical life are really the source of a biowaste. Okay, so how we synthesize our material? So we have collected the biomass or biowaste, like steel or something, watermelon peel or potato peel or banana peel. Okay, so then there are many techniques how we can produce this activated carbon or activated. So the first process is called the pyrolysis of biochar. So what is this? We take our, you can see this, we take our organic biomass, we grind it, and then put it into a furnace for high temperature heating, like 800 degrees Celsius or so, and then we get our biochar. This is the typically carbon product, not basically totally not a carbon, but a carbon structure which can many many species on its surface, etc. Okay, and there are another process which is called hydrochemical synthesis. What is this? So again, in case of pyrolysis, we need high temperature, but in case of hydrochemical synthesis, this can happen around 180 to 250 degrees Celsius. So in this process, we take our biomass and put it into an autoclave. So this autoclave actually is something which holds that biomass with just distilled water, and which works for 24 to 48 hours, and we get something like this, and we after separating we get our hydroxide. This is called the carbon material. But I am saying that this is not fully carbon material, but it has oxygen, nitrogen, etc. Okay, so but this biochar or hydrogen is not enough in our case. So what we need, our main focus is to increase the surface area. Okay, so as an example, I have stated that. So how do we increase the surface area? This is a very good example of our physical idea. That is, a clean wood looks like this, and it has a very minimum surface area. But wood heated by a wood warm looks like this, and it has small tiny pores, many tiny pores, and the surface area has also increased in this. Okay, so to do so, we have taken the biomass, we have powdered precursor, we have drawn the powdered precursor. Then we mix it with acid or base like phosphoric acid, sulfuric acid, hydrochloric acid, or potassium hydroxide, sodium hydroxide, etc. And then we put it into a high temperature heating or a tube furnace. Then we get our activated carbon. This is the material we want, and this activated carbon has a different carbon here. The range of the surface area of activated carbon typically lies between 2000 meters square per gram. You can imagine 1 gram of our material, activated carbon, can give us 2000 meters square surface area. That means 1 gram surface is enough to cover the whole space. Okay, so this is the hydrochar. You can see this is the sample produced in our lab. This is hydrochar, this is biochar, and this biochar and activated carbon looks like same. Okay, but this biochar has very small surface area, but this activated carbon has very high surface area. So, to produce or to make the supercapacitor, we mix this activated carbon with PVDF, polyvinyl fluoride. This is the binder. To make this supercapacitor, we have to put this activated carbon on a current collector like the stainless steel coil. We have used this stainless steel coil. But we want that activated carbon just sticks to the surface of the stainless steel coil. So that's why we have mixed it with the PVDF. And this is the carbon black. Carbon black is a conductive additive. That means it increases the conductivity, the surface conductivity of these electrodes. Okay. Activated compounds are already collected, but to increase the conductivity further, we mix it with carbon. Then this thing is drop casted on a substrate. The substrate is in this case is stainless steel foil, and this drop casting works, and there are some heating and evaporation occurs, and then we finally got our supercapacitor which will be like this. Okay, so our work to build these electrodes are finally done, and we further proceed for the electrochemical testing. Now I will discuss about the electrochemical testing, which we done in case of supercapacitors. So they are the basic electrical tests we all over all the scientists and researchers do for the supercapacitor. What is called cyclic voltammeter or CV. So actually CV is something where we plot the current voltage duration of a supercapacitor. So the idea is it obtains a square state in case of cyclic voltammeter. But in case of capacitors, this ideal behavior is not so, and it goes to this quasi rectangular shape in case of supercapacitors. So basically, get knowledge about why this is a square set obtained for this supercapacitor capacitor. I have small calculations here. So we know that Q equal to C, our secondary knowledge. Then we can take derivative from both sides in relation to time, and we get dq equal to C as the capacitance of the capacitor. So capacitance is the constant. So dq is the current equal to C dvdt. And dvdt is called as scalable. Scalable means how much voltage I am increasing with respect to time. Example 5 millivolt per second or 8 millivolt per second. That is per second 10 millivolt will be increased, and by this way charging or discharging will happen. Okay. So now you can see this thing. So here okay. So if we are charging our device, then K is positive actually. With respect to time, D is positive. And when we are discharging, then K is negative, so that I takes two values, Ck or minus Ck. It does not depend on V. That's why there are two lines does not depend on voltage. The parallel lines to the voltage axis are okay. But in this supercapacitors, the behavior shifts from this ideal case to a quasi-rectangular state. Okay, so actually, basically, I am curious if anyone could tell what is the reason for this quasi-rectangular behavior. What? This not actually looks like HUSS, but this is not actually HUSS. I just want to know that why this ideal behavior in this supercapacitor is not observed. Okay, so this small thing. If you observe anything from ideal to practical life, it changes what's called disturbances, which we don't want, but present in our system. So in this case, actually, you can observe carefully that after this region, the current increases linearly with voltage. This is like some VI characteristic of a resistance. Okay, so actually, our supercapacitor have a series resistance. That is the resistance due to this all electrolyte and all of this. So this resistive effect actually shows this type of behavior, quasi-rectangular behavior. So our supercapacitor has ESR or electrical series resistance. That's why it is quasi-rectangular. Okay, so and from this area of the silica, this is a practically observed area in our lab. So from this area of this silica, we can calculate capacitance per unit mass. Capacitance, why this is why we are measuring capacitance per unit mass? Because if you want to make a high high charge storage capacitor, you need more amount of material. This is basically we are actually presenting our work to the world of researchers. So we are just saying that our material has good capacitance per unit mass. Okay. Actually, you have studied the capacitance, not the specific capacitance. So, but in case of supercapacitor, we actually give the data of specific capacitance for recording. Okay, so by this formula, we can calculate the surface. We can calculate the specific capacitance of our material, and you can see that this A is the area of this curve action, and R is the scan rate. I have already introduced it, and V is the voltage range. There is 0 to 1, there is 0 to 1, and E is the mass of the active material taken for making this electrode. Okay, so there are the galvanostatic charge discharge. That means you are charging your capacitor and then discharging. Of course, for this also, the ideal behavior is not shown, and this type of triangular shape is observed in case of supercapacitors. Okay, so now after this was the electrochemical characterization. Now I am going to discuss about the material characterization. So if you are going to work in this material science field in further future, so you have to gain knowledge about these characterizations, because the characterizations are the main thing in this material science research in material science. Okay, so the BET, the weight isotherm, is something that can measure the surface area of our material. So if I send my sample to testing for testing this BET, then I will get to know the surface area of my sample. That will give per unit mass actually. So I have already stated that the ranges of this activated carbon lies between 2000 plus per kilogram or percent. So these are measured from this BET isotherm or BET technique. Okay, so in BET technique, what they have done, that what they do. So basically, they took our sample, then they they apply highly pressurized nitrogen gas at a particular temperature. Then they note the absorption resorption of isotope that nitrogen gas on our surface, and that's how they have calculated the B and B surface area of our material. And again, this is a very good technique to see our material, that is to see the morphology of our material. So this is the scanning technique or microscopy. So in this case, we can see the surface of the surface or morphological structure of our activated carbon. You can see this is the non-activated carbon. Okay, and this is the activated carbon. So after activation, the carbon has small tiny pores increased on its surface. Okay, then this is a very famous technique of XRD, X-ray diffraction technique, and when we will characterize our activated carbon, we will get this type of peaks. That is the broad peak for this 22 or 24 degrees. Okay, so these are the material characterization. Now we are going to discuss about our work. In our strategy of application strategy of VCP, we have taken this VCP, we powdered and was dried powder. They mix it with three different things. What are the three different things? One is the acetic acid, another is potassium acetate, and another is potassium hydroxide or paving. Okay, then in a particle, obviously they are called a particle weight ratio. Then we have taken this sample in our tube furnace and heat it for 800 degrees Celsius for 2 hours in that. Then we have obtained our activated carbon. Okay, so how I have got this idea? This idea was basically I have got from these papers where they have said that chemicals like KOs and phosphorus activities are corrosive, costly, and poisonous, and they can is not ecologically friendly. And they have also stated that potassium acetate has similar activation characteristics and it is non-toxic. So this idea was from here when we have got this activation from potassium acetate, and they have what this activated carbon for absorption of heavy metals. And in my case, I am actually using this activated carbon for energy storage device in supercapacitor. Okay. So this is the XRD of our samples. Actually, there are many samples. CKS is the potassium acetate activated carbon. CH is the acetic activated carbon. KS is the KOH activated carbon, and this is the biochar. Litchi biochar. Okay, so recently we all have this 002 and this carbon peaks. All of these are amorphous carbons. Okay, and this is the base isotope. And this is the same image of our activated carbon. You can see these are the time ports where electrolytes or electrolyte ions penetrate and give us the capacitance value. Okay, and the surfacing temperature in case of this that biochar is just 2.6 meters square per gram, where in case of potassium acetate activated carbon it is 1.80 meters square per gram. So, this activation process is highly beneficial for our charge storage process. Okay, now you can see this is the C I already said, and you can see the capacity of CKSD, that is potassium acetate is highest among them. Also, the discharge time is highest among all of them. So these are the comparisons, and you can see that after 5,000 charge discharge cycles or 5,000 CV cycles, the capacitance still remains 67%. So I can use it for many times. Okay, and this is the practical device I have made in our lab from digital activated carbon, and these are the electrodes I have used in making this device. Okay, so their current collector, the current collector in this case was copper sheet, and I have just simply coated the activated carbon with the surface of the copper sheet. And this is the video of practical demonstration of this device. Okay. So this device can be actually this device I have made this device so just from 250 milligrams of activated carbon, and it can light up this LED for typically 1 minute. Okay, so this is our lab, the Mandir of our report. For comparison of power obtained activated carbon and capacitance particles with others, I have given this table. And you can see the capacity value is very much accurate, and the surface area is also comparable to the other activated carbons which already have been reported. So there are many applications of the supercapacitors nowadays. Maybe they are actually main part of the electric vehicles. Okay, so if you are seeing for EVs, so nowadays supercapacitor is a very good option to incorporate in the EVs electric vehicles. And there are the references. I like to thank Dr. Suvamay, my supervisor, for this great opportunity and his guidance. I also like to thank Presence University and UPS, obviously. Thank you.
তোমালা আচ্ছা তুমি যে চার ও ও সরি মানে তুমি যে চারটা লেভেলের উইন্ডোজে তুমি কম্পেয়ার করেছো লাইক এই কিন্তু অনেক বেশ কয়েকটা আছে বাট এরপরও তো আমাদের বায়োমাস এক্সিস্ট হয় সেইগুলোর ব্যাপারে কি ভাবো তুমি লাইক লিচিতে ফিল্ডটা তুমি চুজ করেছো এটাই কেন চুজ করেছো আরো কোনো কিছু চুজ করতে পারছো
হ্যাঁ এবার ডিসিপ্লিনটা কেন চুজ করেছি এটা একটা ভালো কারণ হচ্ছে যে আমরা যদি দেখি মানে আজকে কিছু রিসার্চ দেখা গেছে যে অ্যাক্টিভিটি কারণ প্রডিউস করছে তাহলে বায়োমাস থেকে ওভারঅল স্ট্রাকচারটা আছে যে সারফেসটা ছিল যে সারফেসের স্ট্রাকচারটা এই রিটেন করা যাচ্ছে তাহলে যখন কার্বন অ্যাক্টিভ কার্বন লিচি যে সারফেস আছে হার্ড সেল টাইপ স্ট্রাকচার তারপর অনেক পোরস আছে ঠিক আছে তো সেটা আমি একটু পুরো সেক্টর কারবো আর স্ট্রাকচার সেটা কিন্তু এই হার্ড সেলটা আমার স্মল কারণ আমি বানানো হচ্ছে একটা এলিমেন্ট আমার অনেক পোরস কিন্তু তাকে আমি একটা চার বিশেষ করার পর সেটা একটু ভেঙে গেল তাহলে একটা মাঠে বিশেষ পাবো বুঝে গেছে তাহলে আমাকে তৈরি করতে হবে এমন একটা স্ট্রাকচার যে স্টেবল হবে যেমন পোরাস মানে যার সেন্সিটিভিটি ভালো হবে আর হচ্ছে এটা চলতি চয়েস করা হচ্ছে আমাদের ডেভেলপমেন্ট বায়োলজি বাট মানে দেখা গেছে যেরকম প্রপার্টি আমরা ফিজিক্যালি দেখতে পাচ্ছি সেটা অনেক ক্রিয়েটিভ করার চেষ্টা করা হয় যে যখন আমি বিসিবি ট্রেনিং করলাম তো ওটা কিন্তু অনেক ভালো সার্টিফিকেট
তাহলে তোমার মতে এর থেকেও আরো বেটার স্কোর ক্যাপাসিটর তৈরি করতে পারে এবং এক্সিস্ট করে তো
হ্যাঁ এবার হচ্ছে একটা জিনিস হচ্ছে আমি যে একটা ফ্যাক্টরি লাগাতে চাই ফ্যাক্টরি প্রডিউস করতে চাই আর আমি এমন জিনিস চাইবো যেটা হচ্ছে ভালকে প্রডিউস হয় অ্যাকচুয়ালি লিচিগুলো ভালকে হয় কিন্তু যেমন সুগার প্রডিউস হয়ে গেছে বা যেটা হচ্ছে সুগার কেন দেখে যেটা হচ্ছে আমাদের মানে আপেল সুগার কিন্তু সবই ফেটেছে সুগার কাজ হয়ে গেছে তো যেগুলো ভালকে প্রডিউস হয় সেগুলো থেকে কিন্তু বেশিরভাগ কাজ হয়ে গেছে তাই জন্য আমরা বেশি ওভারঅল যেগুলো হ্যাঁ লিচিগুলো চলবে কিন্তু সিএসএস স্ট্রাকচারটা এরকম আর এই সিএসএস স্ট্রাকচারটা কিছু ওল্ড স্ট্রাকচারটা সেটা খুব ইউনিক তাই জন্য আমি ফিজিক্যালি নিয়ে কাজ করি
তুমি কিছু ভেবেছো এরপরে যে এরকম কিছু একটা
আমার অনেক কিছু করেছি বিভিন্ন ধরনের গ্লাসের সাথে করা হয়েছে ঠিক আছে এবং ব্যাপারটা হচ্ছে এটা পরিবেশ বিভিন্ন বায়োগ্যাসের ক্ষেত্রে আলাদা রকমের ভ্যালু ভ্যারি হয়ে যাচ্ছে সার্ভিসে আমি একই অ্যাসিড কিছু একই মিক্স করছি সব সেম টেম্পারেচার সেম সব কিছু কিন্তু যখন বায়োগ্যাস চেঞ্জ করবো তখন কিন্তু সার্ভিসের ভ্যালু ডিফারেন্ট হয়ে যাবে কারণ সব বায়োগ্যাসের ক্ষেত্রে তাদের যে কনস্টিটিউয়েন্ট সেলুলোজ লিগনিন সেলুলোজ লিগনিন এগুলো কন্ট্রোলের রেশিওগুলো চেঞ্জ হয় তো ওই রেশিওগুলো ডিপেন্ড করে কিন্তু লিগনিন স্ট্রাকচার থেকে ফর্ম করে তো সেটা ওই সেলুলোজ পুরো স্ট্রাকচারের উপর মানে কোডটা কেমন হবে কতটা বড় হবে সিঙ্গল আছে এরকম এরিয়া আছে এটা সাইজ দিয়ে মানে কোডগুলো আমার একটু বড় হলে হবে ছোট হলে হবে ঠিক আছে এই জিনিসগুলো লিমিটেশনগুলো এগুলো মানে প্রভাব পড়ে তো ব্যাপারটা হচ্ছে যে ডিফারেন্ট বায়োমাস নিয়ে করে রাখা এই যেটা বেশি আসছে সেটা ইউজ করে এরকম মানে হচ্ছে ডিফারেন্ট অথররা ডিফারেন্ট বায়োমাস ইম্পোর্ট করে যাচ্ছে বেনিফিটস অনেক কিছু আছে যেগুলো বায়োমাস প্রডিউস হয় হয়তো শুধু তাদের জায়গায় তৈরি হচ্ছে মানে আমরা গ্লোবালিও করছি কিন্তু তারা ইম্পোর্ট করছে যেহেতু ভালো দিচ্ছে ঠিক আছে মানে ভিডিও করে ভাবি কেন ভালো দিচ্ছে কিন্তু ভিডিও ওগুলো কিন্তু অনেক করা যায় যে আরো কিভাবে বাড়ানো যায় সেগুলো কিন্তু ভিডিও করা হয় আমার ক্ষেত্রে ডিজিটাল নেওয়া হচ্ছে এই কারণ হচ্ছে ওদের স্ট্রাকচার যে সিলটা হার্ড স্ট্রাকচার হার্ড সিলটা আর ওর সার্ভিস করে আছে তো সেটা কিন্তু রিটেন করার চেষ্টা যদি অ্যাক্টিভেট নাও অনেক জিনিস ছিল যেমন ইলেকট্রোলাইটকে আমরা ইউজ করছি ইলেকট্রনকে আয়নকে অ্যাবজর্ব করার জন্য ইউজ করছি ঠিক আছে তো সেরকম অ্যাক্টিভেট নাও আরো অনেক জিনিস হবে যেটা দেখা হেভি মেটালকে অ্যাবজর্ব করার জন্য ইউজ করছি এখানে অ্যাক্টিভ ফিল্ড বলতে বলেছে যেটা যেহেতু ইউ সার্ভিস এরিয়া ইট ক্যান অ্যাবজর্ব ইজিলি or any ion or any particle is on its surface. It's because active what is active compounds also active carbon শুরুতে মূলকে মনে করছি তার পিডিডি বায়োডিগ্রেডেবল আছে যেটা কাটতে লাগে তারপরে আলু ব্যাকগ্রাউন্ড মনিটরিং পার্ট সারা হচ্ছে তো এইভাবে কিন্তু নিশ্চয় পুরো মানে অ্যাক্টিভ কম্পাউন্ড করে কিছু কাজ করছে
আর বিশেষ করে অ্যাক্টিভ জেলের ডিফারেন্স কিছু এটা
সিন মানে আমাদের কিন্তু জেল থেকে কিছু আছে না ইলেকট্রোলাইট আমরা ইউজ করছি অ্যাটমসফিয়ার এর উপরে জেল ইলেকট্রোলাইট আছে ঠিক আছে কিন্তু অ্যাক্টিভ জেল বলে এরকম কিছু অ্যাক্টিভ জেল বলে কিছু নিয়ে গেছে যে অ্যাক্টিভ জেল এই ওয়ার্ডটা কিন্তু এখানে মানে আমাদের সুপার ক্যাপাসিটর
এটা কি মানে ওই ব্রড এরিয়ার মধ্যে কি সেটা
ক্যাপাসিট্যান্স হলো মানে ডাইরেক্টলি এরিয়ার সাথে এটা করছে এই এরিয়া যদি বাড়ে তাহলে ক্যাপাসিট্যান্স বেশি এবং অন্য যারা রিপোর্ট করেছে তারা যারা ক্যাপাসিট্যান্স যেমন এটা এরিয়াটা অনেক বেশি এই ক্যাপাসিট্যান্স পুরো কমে গেছে তো এটা কিন্তু নির্ভর করছে
যেখানে টেলিগ্রাম পেয়েছি এবারে টেলিগ্রামের জন্য ডিফারেন্ট ইলেকট্রোলাইট ইউজ করেছি ওইটা হিসাবে
হ্যাঁ এবার বিএফটা হচ্ছে মানে যেটা আপনারা যেটা পড়ে আমি দিয়েছি আমার কিন্তু আমি ইউইস মানে যে কোনো ইলেকট্রন নিয়ে অ্যাক্সেস করতে পারি বা এরকম বেসিক তো ইউইস ইজ সালফারিক অ্যাসিড এগুলো আমি পুরো টেস্ট করে দিচ্ছি এবার আমার কাছে ইউইস এক্সেল করে দিচ্ছি তাই ইউইস হয়তো মানে আমার কি আয়রন হচ্ছে মোবিলিটি আছে তাহলে আয়রনের যে একটা সাইজের ব্যাপার আছে কারণ এই সিচুয়েশন ক্ষেত্রে যে আয়রন সাইজটা আছে তাহলে কি ইউজ করতে হবে তাহলে হচ্ছে আমার যে সাইজটা আছে এর তো বেটার হবে ওই মোবিলিটি বা আয়রন রেডিয়াস এইগুলো হ্যাঁ I will be from the organic acid. Can you save that? Can you carry it? You know, the Asha cycle is but has regulate to 90% of the loss.
anyone next সেটা সময়টা তো কি কম্পেয়ার করে দেখতে তোমার সুপার পাওয়ার ক্যাপাসিটরের চার্জিং টাইম আর যদি নরমাল যেটা ইকুইপমেন্ট ব্যাটারি যেটা মার্কেটের তার চার্জিং টাইম
Acetate equivalent property is that both fast charging discharging flow. Yes. So consider high power density and power density high rated to charge back or high discharge. Here also lithium ion batteries is comparator. Lithium ion batteries is comparator to দেখতে পাই এনার্জি ডেন্সিটি লিথিয়াম ব্যাটারি ডেন্সিটি এনার্জি ডেন্সিটি অনেক হাই I don't know our molecular motion is very fast as well. Shape structure. Because supercapacitor has to charge like a resistor. Then after that compare put by the we have to design not to write. Then supercapacitor like हम इसे design करना that you the charge का हम product में accept. और supercapacitor install है fusion of install है.